Hey, what's up? Welcome back to the channel. It's Brett with American Revival Crafts. Today, what I'm going to be showing you is my top 3 beginner projects for the CNC. Make sure to check out the description below because I'm going to be offering all of these files for all of these projects for free for you to try out at home. All right, come on, let's fire up the CNC. So here's our first project. This is a tool accessory tray for your CNC. The reason that this is a really good beginner project is because it uses inexpensive or scrap material, which could either be MDF, that's what I'm going to use in this case as an example. You can also use plywood or even a softwood like pine if you had a project panel or something like that left over. It could also be used for this project. Any softwood is going to be good for a beginner because it's going to be really easy on your bits. And if you have any crashes or make any mistakes, it's going to be a lot less likely to break a bit. So here in our example, this included file is going to have a sample tray that I've designed for my Husky tool cart to fit in one of the drawers, but this can be modified any way that you want. But let's go ahead and start with our first thing. It's this setup wheel here, our job setup. We're going to click on that and we're going to type in our stock size. In my case, I'm using a piece that's 19 inches by 22 inches. And I've measured its thickness with calipers, which is extremely important to do on every project. And it's about 0.62 inches in thickness. We're going to make sure that our zero height is measuring from the top. And our toolpath 0 is set to the bottom left corner, the lower left. Our material, we're going to put softwood, the machine's Shapeoko 5 Pro. And retract height, I've changed to 0.2 inches. Usually this comes stock at 0.5. It's a good idea to keep it at 0.5 of an inch when you're first starting out. That's going to tell the machine how far up to raise the bit as it's moving to its rapid positions throughout the workspace. So the higher it is, the less likely you're going to crash into something. So we'll leave it at 0.5. As you get more experience, you could lower this down to like 0.2. And that's going to save you a little bit of machining time because that rapid movement is going to take less time to accomplish. But we'll just leave it at 5.5 for right now. Okay, so our job is set up. You'll notice in this file, I have a perimeter square and then all the other small areas for various parts. Now again, like I said, you could easily modify this. If you want to change this to whatever dimension you can, not only in the job setup file, but in this transform file. I mean, you can make this thing 24 by 24 if you want, and you can move these around anywhere that you want. It's totally up to you to do what you want with this file. In my case, this is a pretty good setup. I have room for bits down here for the tease nuts, small trays, large tray, calipers, caliper batteries, extra bits, clamps, squares, different clamps up here, and some other hold downs and cam clamps up here. So let's go ahead and make the toolpaths. Go up to the toolpath tab here. The toolpaths that we're going to use on this project are really simple. It's actually only one. It's going to be pockets. Okay, so we're going to take material out of these, in between these lines here to create a pocket, which is going to make a space for us to hold our items. The only other toolpath I guess we're going to use is a drilling toolpath, and that's going to be to make these 1/4 inch holes right here. So we're going to be doing a pocket toolpath for most of this and a drill toolpath for just a small portion of it. The first thing we're going to do is create our pocket toolpath. So I'm going to highlight everything and I'm going to hold down Shift and I am going to click on our 1/4 inch circles that we're going to be drilling. Everything else on this screen right now that I have highlighted is going to be pocketed. So I am going to go to the Toolpaths tab. I'm going to click on Pocket, use current selection, and I'm going to change my bit to a 1/4 inch. I'm going to the softwood selection in the tool library, and I'm going to use the 201 end mill, which is the end mill that comes with the Shapeoko. So if you have this unit, you will have this bit, and it is a very common bit. The 1/4 inch end mill is one of the most common you're going to use. It's definitely a good idea to have a lot of those, 2 or 3 on hand at all times, upcut, downcut. So for the step over, I'm just going to change this to 0.12 and depth per pass. Since I'm using MDF on my machine, I know I can go 1/8 of an inch, 0.125 per pass with this 1/4 inch end mill, and I'm going to leave the speeds and feeds the same as they recommend here for stock. These are really good, safe feed rates and plunge rates that Carbide 3D recommends in their tool library. You can experiment with these. You can always increase them if you want. The nice thing about using Carbide Motion is that you're able to increase the speed while the machine is running. You can actually bump it up even 100%, up to 100%. So you can increase it on the fly when the machine's running. So if I'm at 75 feed rate right now, I can bump that up to 150 just on the controller as I'm running the job if I want to. So I'm going to leave that at 75, and I recommend if you're new to leave it at what Carbide 3D recommends. Except for the step over and the depth per pass in this situation. Okay, so here is our tool pass generated. The next thing I need to change is the start depth and max depth. So obviously the start depth is going to be the top of the stock, and the max depth on these, I'm just going to go down 0.2 inches, and I'm going to name these pocket tool path. Okay, so it's generated the tool path. It's given us an estimated time of 54 minutes right now. Next thing we're going to do is do our drilling toolpath. So I'm going to highlight our circles here and click on drill, use current selection. I'm also going to use the 1/4 inch end mill, the 201 end mill for this. And I'm going to put these down to a depth of 0.25 inches. And I'm going to change the name to bit holders. Now we have all the tool paths assigned for this particular job. Let's go ahead and simulate. I just unclicked show tool paths. That'll clean up some of the lines as you'll see on the simulation. But there we have it. You can jog around. You can angle this. Carbide Motion really gives it a really nice simulation. So there you have it. So we're about 54 minutes for this job. If you want to experiment, you can get that time down a little bit. If you feel comfortable, just for example, if we switched this to about 100 inches per minute, and then on MDF with a 1/4 inch end mill, that is still fairly conservative. That's nothing crazy. It's going to get us down to 42 minutes. So let's stick with that. Okay, I'm going to save our tool path and send this over to the machine. Okay, so for my clamps, I'm going to be using just the tease nuts and clamps that come with the Shapeoko. And these are great because they're plastic, so if you do crash into them, like I have here, it just cuts right through them. No harm, no foul. So I'm just going to set these up in the hybrid table and go ahead and tighten them down. For these ones here on the front of the table, I like to put a little piece of scrap wood underneath it, just so I'm able to tighten this down. And then I'm going to put about 3 or so additional clamps on here. So aside from making sure that you have flat and milled stock all ready to go before you put it on the CNC, one thing you can do to make sure it's flat is after you clamp it down, you could take a straight edge and just run it on the board and make sure it doesn't rock or that there's any low spots. And this board was a little warped just because it's been laying around the shop for a while, but once I clamped it down, it's nice and flat now. As you get a little bit more experience, something that you can do is, surface the entire piece on the CNC with a surfacing bit, or prior to putting it on the CNC, you can make sure it's milled with traditional woodworking tools like a jointer and planer. So here you can see the bit setter measuring the tool. So now we have the machine initialized and we have our material secured to the spoil board. The next thing we need to do is to set our 0 point for the machine. So I have a probe that does that with this unit. It's the Bit 0 by Shapeoko or by Carbide 3D, but I'm not going to use it in this situation just in case you don't have one. I'm going to show you how to do it manually. It's still very easy. So what I'm going to do is I'm going to use my wireless controller here, and I'm just going to jog the machine over to the X and Y 0 point that I want to set. So all I'm doing here is eyeballing the center of the bit with the bottom left corner of the material. And once I have everything where I want it, I'm going to lock that in on Carbide Motion by setting 0. on the X and the Y. I'm going to hold off on the Z. We're going to take care of that right now. So I like to jog the bit somewhere towards the center of the work area, and I'm going to go ahead and just manually lower the Z-axis down until I'm just touching the material. And one thing you could do is put a piece of paper under here. That's going to give you a little bit of clearance, and you're going to lower the bit just till the paper drags on the bit. But in this circumstance, it doesn't have to be that critical. So I'm just going to run this down. I'm going to kind of spin the bit until it just starts trimming a little bit off, and right there is where I'm going to set it. Okay, now we have everything zeroed. The machine knows where it is in the space. We're going to go ahead and click on Run and load our file. And this will bring up a quick overview of what we're doing. You can also see a preview, top view, front view, and isometric view. That all looks good. Hit done, and we can start the job. Okay, so we got our file cut. Our tray's looking pretty good. You can notice that because I'm using an upcut end mill, it is ejecting the chips upwards, which is good. It helps us cut fast and it creates a clean bottom, but it makes the top a little bit fuzzy. So what we're gonna have to do is sand the top of this just real quick to get rid of those fuzzies, but other than that, we're almost done. So here's our completed tool tray. Let's go ahead and get this in the drawer and load it up. Okay, so there you have it, our first beginner CNC project, the tool accessory tray. This is just an awesome first project for so many reasons. It's cheap, it's easy to build, it's forgiving, and most of all, it's really useful because when you're first starting out, you need a place to put all this stuff. And maybe you won't have all this stuff when you first start out, but you will have a lot of it, and you're gonna continue to grow. So this is a project that's gonna grow with you. Another thing I'll say about this is, even when you're experienced with CNCs, you will make mistakes. On my file, I kind of I didn't make these pockets quite big enough for my cam clamps here, or these clamps here either, but even if you make a mistake on it, it's still usable. I'm still going to use this. It's fine. I'm going to change it in the file so it'll be good for you if you decide to download this. But it just goes to show that no matter how much experience you have, it's okay to make mistakes and it's still really usable. So don't be afraid to try this. Okay, so for our next project, I've got a 3/4 inch sheet of MDF back on the CNC. This time I've spray painted it black, and we are going to make an American flag. And this is just a really awesome beginner CNC project because they look so cool. You can sell them. They go like hotcakes. Even though there's a ton of people making them, there's a lot of different variations you can do with them. So there's always something new and exciting that you can make, or you can change to them to really make them cool. So I highly recommend this as a second CNC project. A lot of the same processes are going to be in place from our tool tray, like our work holding and the way we set up our file and our machine zeroing. But in this project, we're going to add V-carve engraving to the lineup. I'll show you how it's done. So the tool paths we're going to be using for this project are a V-carve toolpath for the stars and for the words. We're going to be using a contour to cut out the perimeter of the flag, and also a pocket toolpath to pocket out the stripes. All right, so whenever we start a new project, we want to always start with our job setup. So for this project, we're going to be using a piece of MDF, which I painted black, and it is 24 inches wide and 39 inches tall. Our thickness is at 0.67 inches. Again, we're zeroing from the top, and our toolpath 0 is going to be the lower left, and all these settings are going to remain stock. One thing I want to say about the stock size, in this example, I'm going to show you how to make this flag by cutting it out of a larger piece of stock. I think that's easier sometimes when you're starting out because you're able to put clamps around the whole perimeter of the project to make sure it's all held down nicely. You could use an exact size piece of material. So like a 22.5 by 12 inch piece for this flag. But you wouldn't be able to use clamps around the perimeter in some of the areas unless you set them perfectly, because some of the tool paths are going to run into them. So I like to have a larger piece of material just to start out. I recommend that. So that way you don't worry about anything crashing in, any bits crashing into any of your clamps or anything like that. That'll make more sense later when I show you this actually running. So you can see this is our large piece of MDF here, and then this is our actual project. So I'm going to highlight this whole piece, and I'm going to move it just up a little bit. Again, that way I have space on the left, I have space on the right, the bottom, and on the top also to clamp this down, and I don't need to worry about the end mill hitting any of the clamps. Okay, the first tool paths that we're going to assign are the stars and the words. We can group those together because they are both going to be a V-carve toolpath. For our tool, it was already selected. We're going to use the number 301 90-degree V. I like the way this looks for the stars and for writing, and we're going to leave all these settings the same. This is just the stock softwood parameters. Again, these are very conservative. You can definitely up these if you like, but we're just going to stick with the conservative stock settings in this example. The starting depth is going to be the top as always, but whenever you're V-carving, you want the total depth to be the bottom of the stock. In our case, our material is 0.67 inches, so I'm going to put 0.67. So now that we have our V-carve toolpath set up, let's go ahead and set up the pocket. So now I'm going to hold down Shift and I'm going to left click on all of these rectangles, and I'm going to click on the pocket toolpath, use current selection. My end mill again is going to be a 201 1/4 inch end mill. That's already selected. Start depth is the top of the stock. Max depth on this is going to be 0.1 inches, and I'm going to change this name to stripes. If you want to go back and edit your toolpaths at any time, all you need to do is go onto the left menu here and double click on whichever toolpath you want to change. And I'm going to edit my 1/4 inch end mill here to have a step over 0.12 inches, and I'm going to change my depth per pass to a 1/4 inch. Again, those are still pretty conservative settings when using MDF or a softwood, and that's going to take my time down significantly. Okay, so now we got a V-carve, we've got our stripes pocketed. Last thing we need to do is select the outside perimeter, and we are going to do a contour cut. That is going to cut all the way through all of this material. 1/4 inch end mill, 0.125 depth per pass, plunge and feed rate, RPMs are going to stay the same. But for the depth here, I'm going to use the stock bottom, which is 0.67 inches, and I'm just going to change this to 0.675. I'm going to go a little bit lower than the stock just to make sure I cut through. Okay, the next setting that's really important is your offset direction. This is going to tell the tool where to cut on this line. Right now it's set on to inside left of the line. So this is actually going to make our square, if we had it set like this, our rectangle would be smaller than what I drew on the file by a 1/4 inch by the size of the end mill. And we don't want that. So we're going to go ahead and switch this to the outside right. And you'll see that changes the toolpath from the inside to the outside. Now we're cutting this rectangle out exactly the same size that I had it drawn in the file. You can also switch this to a no offset, and that will cut right on the line. And that's useful for some circumstances, but in this case we want to go outside right. And you'll see I have these squares with an X on them around the perimeter of the file, and those are tabs. Those are areas that my contour cut is not going to cut. It's going to leave a small amount of material there so that this piece, our main flag, will not float in the middle of our stock when it cuts all the way through. This will hold it in place when we cut all the way through. And that's really important, because if you do not secure your workpiece and you cut all the way through it, it's going to move and it's going to bounce around and it's going to get all messed up. So if you're not securing this some other way with like double-sided tape or CA glue and blue tape, you definitely want to use tabs. And to start out, I would highly recommend them. Over here in the tab file, you can actually set the parameters for what size you want the tabs. I just leave that stock for the most part. Okay, there we have it. We have all of our tool paths assigned, our V-carving, our stripe pockets, and our perimeter cutout. Remember, if you ever want to reorder these tool paths, all you have to do is left click them and drag them, and you can put these in any order that you want. But in this case, I do like having it in this setting. I'm going to start with the 90-degree V bit. to carve out the stars and the words. And then I'm going to pocket out my stripes. I don't want to put my perimeter cutout here next necessarily, because if I did that, I would have all these tabs supporting the workpiece. But ideally, you want to have the most amount of support for your workpiece when you're doing this much of a pocket operation. So I'm going to go ahead and change my perimeter cutout to the very last thing that we do. That way, this contour will not be cut, and it'll be supported fully by the clamps, and everything will be nice and sound. We'll go ahead and look at the simulation. And there we have it. You could see those tabs, what those look like in this simulation. All right, let's go ahead and send this to the machine. So I'm going to use a 90-degree V-bit for this tool path. Let's go ahead and get it loaded up in the spindle and get it started. So here's a quick tip when you're engraving stars. It's really important that you have your zero height set perfectly, and it's also really important that your material is flat. If it's not, your stars will come out to be different sizes when you actually engrave them over the union space. So I've taken extra care to make sure I've double checked and triple checked my zero height here where the union's going to be specifically, and I've also put my ruler on this portion of the MDF and made sure it was flat by applying a little extra clamping force. That's just a little trick that I've done to make sure that even though you might have some slightly warped material like pine or MDF, like in this case, the MDF I'm using is scrap, so it's been kind of leaning up against the wall for many months, so it's a little bowed. So those are some quick tricks that you can do to help flatten out your board to make sure your stars are nice and crisp. Let's see how it turns out. One other tip I have is get yourself a sanding block here. This is just a scrap piece of 3/4 material. I've glued on a strip of 80 grit sandpaper on one side and 120 grit sandpaper on the other. I'm going to use this to sand in between the stripes where I pocket it out, and also some of the chamfered edges of the flag just to knock down any burrs. This is really easy to use, especially on MDF because it sands so easily. But if you make a lot of flags, this is a nice little tool that I always keep right on the CNC because I use it all the time for lots of different stuff. All right, let's get this cleaned up and finished up. And for project number 3 on my list of my top CNC projects for beginners is going to be a valet tray. Now, a valet tray is simply a pocketed tray that you can put on your nightstand or by your front door to throw your keys and wallet into when you're not using them, and so you always know where they are. Very popular. These are all over the place, but I think it's a great project, again, because it's simple, it's useful, everyone likes them. You can give these as gifts, you can try to sell them, you can do so much with them, and they're so simple to make. Now, we're also going to be building upon the skills we've learned with the past 2 videos by adding a new tool path to this project. And it's not even really a new tool path, it's just a different use for one. So we're going to be using a contour tool path with a 90-degree V-bit installed around the perimeter of our cutouts, and that's going to give us a chamfered edge. It's very convenient, really makes it look finished. So let's go see how we do it. Okay, so first thing I'm going to start with is this large pocket here. This is what your stuff is actually going to sit into on the tray. So we're going to select the vector, go to pocket. We're going to use our 1/4 inch end mill. We're going to edit the settings though. We're going to do again step over of 0.12, and our depth per pass is going to be again a 1/8 of an inch. This is poplar that I'm using, so it is still a pretty soft wood. This end mill will blast right through it. The other settings I'm going to leave the same, just like the other projects. Feel free to change those if you want though. Okay, our start depth is going to be 0. Our max depth on this is going to be 0.51 inches. Now, the reason I did 0.51 inches is because I'm using a 1/4 inch end mill that's going to be going down 1/8 of an inch per pass. So if I were to do 0.5 inches, this would take 4 passes for the tool to get to the final depth. But I want to go ahead and do a final 5th pass, which is more of like a finishing pass, and it's only going to cut off 0.01 of an inch. That's the reason why I'm doing this at 0.51 inches. It's just one little trick that you can do to help create this a little smoother. You can also create a separate toolpath for a finishing pass and change the step over to make it overlap as it cuts each time more, and that'll help remove some of these mill marks that you'll see when we actually cut this out. But this is just a beginner way to do it, and it gives a pretty clean cut. Let me just show you what happens if we go to edit and we change this step over to maybe, let's say 0.075. You'll see what this does to the simulation here. It's going to tighten up these lines, so that means it's going to take longer because the bit is overlapping as it's going around in a circle a lot tighter. But that's going to give you a smoother cut. It's just going to take more time. In this case, I don't think it's necessary. I'm going to change that back to 0.12. That's usually the step over that I'm going to change the step over to 0.12. That's a pretty good step over in my opinion for most operations, especially basic operations. So we'll leave it that way. Next thing we're going to do is we're going to engrave our initials. So that's going to be a V carve. So we'll select our vector. Our tool is again, we're going to use a 90-degree V-bit. The only difference here is our start depth. It's not going to be 0 because we're pocketing out this section here, so it's going to be lower. So this start depth needs to be 0.51 inches. That's the depth that we're making our pocket. So start depth is going to be 0.51, and our max depth is just going to be the stock bottom. And that's going to give us a nice V carve on here. Now I'm going to do our perimeter cut. This is going to be a contour. I'm going to use the 1/4 inch end mill. We'll change these parameters again to 0.12 depth per pass. Everything else is going to be the same. We're going to change this only to 0.125 per pass, 1/8 of an inch per pass. Our start depth is 0. Our max depth is going to be 0.755. I just want to go just a hair lower. Now, when you use this file, you're going to have to change this to whatever stock size that you're using. So make sure you get a set of digital calipers on it to measure what the thickness is. And our offset direction is going to be, again, outside to the right. Okay, now the new toolpath we're going to use for this job is we're going to create a second contour on our perimeter outline, but we're going to use a 90-degree V-bit, and we're going to leave all this stock. And what this is going to do is create a chamfer on the outside of the cut and on the inside pocket. So I only want to go to a max depth of 0.1, and I'm going to change this offset direction to no offset. So it's going to cut right on this line. Now, when I set this up, I only selected this outside vector. What I want to do is also select this vector, the inside line and the outside line. I'm going to go ahead and click on both of these, change vectors to selected. There we go. So now I have both of them, 2 vectors selected, the outside and the inside. No offset, and I'm going to change this to chamfer. Okay, so we're going to cut out our main pocket. We're going to engrave our initials. We're going to do a perimeter cutout with tabs, and then we're going to chamfer the outside perimeter and the inside pocket line. Let's see what this looks like on the simulation. Looks pretty good. You can see our inside and outside chamfers. Oh, one thing I forgot. You can see on our chamfers, it is showing the tabs here. So let's go back. Let's hide the simulation. Click back on our chamfer toolpath. We need to make sure we click this button here, ignore tabs. If you don't click this button, it's going to raise the bit once it gets to these tabs and won't look right. So we want the tabs for our perimeter cutout, but we don't need them here for the chamfer. So we're going to ignore those, and I'll show you what that simulation, how that changes here. And there we have it. Our tabs have been ignored for the perimeter chamfer. All right, let's go get this on the machine. I am using 1¼ poplar for this. You can use anything you want. This file is set up to be used with stock as thin as 3/4 of an inch. All you have to do is make sure when you're setting up the file, you go to your job settings and you make sure you input your material thickness. If you're going to be using carbide crate like I have set up. All right, we have the 90-degree V-bit installed. I'm gonna leave the dust boot off on this tool path just so you can see how it's cutting, and plus my vacuum's full right now anyway, so it's not really doing much. I had to bring in some reinforcements earlier during that perimeter cutout to take care of some of the dust, but I'll empty that out later and we'll change it up. This is our last tool path of the day. Check it out. Okay, so there you have it. There are my top 3 CNC projects for new users. Today we made a tool and accessory tray for all of our parts and pieces of our new CNC. We also created a cool American flag with the Pledge of Allegiance. And we made a simple valet tray to keep all of our stuff when we get home from work. Now, if you're interested in working on some of these projects on your own, I have the free files available for download on cutrocket.com. You can find all that information in the description below, but they are 100% free. And of course, as always, if you like this video, please give it a thumbs up. It really helps out the channel. And if you really like the content, I please ask that you subscribe to the channel because we have a ton planned for the future. A lot more videos coming out here very soon. Your subscription really means a lot to us. And if you have any questions or comments, make sure to please leave them down below. We can continue the discussion. And hey, if you have any suggestions for videos that you'd like me to cover, please leave them down below. I'd love to hear from you. Or shoot me an email. All right, thanks a lot for watching. See you on the next one.